So we will start the theorem 9.4, same chapter. Circles. Chapter is 9. For class 10. Page number will be 193. In the previous class, what we finished was 9.3. In 9.3, what we have seen is that the circle having one semicircle inside, half of the circle, of course, and the angle made on one of the side of the circle, subtended by the circle, inside the circle, that is going to be 90 degree in any case. So that is what we have already finished. Now in 9.4, what we will do is the converse will try, the opposite of the same. How? That means if it is 90 degree, then it has to be inside the semicircle. Okay, remember the previous one was, if it is a semicircle, inside a semicircle, that angle will be 90 degree, right angle. But this time, if it is a 90 degree, then it will be a semicircle. Okay, very easy, very short also. So it will be called a converse. Of course, the theorem will have statement as well. (9.4). It states that we also write it as converse of Th-Wenz's theorem 9.3. Okay, if an arc of a circle subtends a right angle means 90 degree, right angle at any point of the circle in its alternate segment. I'll explain all the terms. Then it is a semicircle. How it is converse of 9.3? First we'll understand. If it was a semicircle, then it will be right angle. That was 9.3. Okay, 9.3. If there is a semicircle, then the angle inside will be right angle, 90 degree. And we already proved that. You can go to that video 9.3 and you can understand. In this case, what happened? If there is an arc, okay, I understand what is the arc, makes an angle 90 degree inside the circle, okay, already 90 degree, then that would be automatically a semicircle case in its alternate segment. What is that? Whole of the meaning we try to understand. If there is a circle, you do not draw it right now. Then if there is an arc like this, suppose this is the arc, okay, this is the arc there, and further we are not talking about diameter, nothing, no center, nothing. We just say that in the alternate, if this is the arc, the alternate is the other one. Okay, this is one segment, this portion is called segment, any circle, if this is the line here, any chord, this part is called segment. Okay, so of course this is one segment, the alternate is the other segment. So here if we talk about this arc AB, that means the alternate segment will be the unused one, the upper one. In the alternate segment, if we have an angle like this, okay, and if that is 90 degree, then we need not do much. We should know that it is that this line is passing through the center. Okay, simply that. So that this is a semicircle. So that is what we have to prove it mathematically, that we are going to do in this case. Okay, that is the rough meaning of that. So now writing part, you can write this statement, you can write Now that statement will be followed by a given, just like the way we solve problem in maths 2. Given what it has, an arc AB of a circle, the given circle, with center O, angle ACB equals to 90 degree at C of BA. BA and this means the alternate segment. Okay, if this is the arc here, AB is the arc like this. Okay, if there is a circle, don't draw this part. If suppose this is the circle AB, this is the arc AB, BA means this one. Okay, even if you miss out, no problem with that, it is understood. Now what we need here is, we need to prove 90 degrees already there, so here we will prove that AB arc is a semicircle. What we have to prove is, this is there, this is a semicircle. We have to prove that this is the semicircle. Okay, here now up to here we have to prove it, and we will go in. Semicircle proving is our aim. Now for doing that, we will of course have one diagram already with us, which is this one. Okay, we'll not make any center on it right now. We will only have A, B here, and a point here somewhere C, and it will be like this. Now we have to prove that this AB is the this is the semicircle. So in order to prove that, we'll use construction, we'll use some extra idea. So that construction will be joining this line AB. Okay, that we'll write in construction because we did it separately, it was not in the beginning. Join A, B, the dotted line means it was done in construction. Okay, after that we start the proof. Proof of course is easy again. 9.2 was very important that we are going to use again. 9.2 was used in 9.3 also. 9.2 will be used in 9.4 also now. Okay, remember 9.2 was important. 9.2 was used in 9.3 also, and now it will be used in 9.4 also. So the statement of 9.2 is important even for solving many exercise problems. Okay, so how we'll write it? Since the angle subtended by an arc at the center, very interesting, center, this was 9.2, remember center, if you have revised enough you will automatically know what is this. Center is double the angle subtended by it at any point on the remaining part of the circle. Fine. So if it is so, what is the big deal here? Okay, it allows me to write that here in this our diagram. What it is going to allow me is that we choose a point here O, but we do not know it is a center. Okay, what we will do is just change it here. Join OA and OB. Okay, till now we are just joining OA and OB, but we do not know it is a straight line. That we are going to prove. Okay, that is the way we have to tell it is a diameter. Okay, very important. When we are joining not directly AB, we are joining OA and OB. Okay, it may be like this also. OA may be like this, OB it may be like this. If it is like this, it is not going to be 180 degree. Okay, but we assume it is unknown, so we join. Where is A, where is B, we do not know. So now if it is, then it will follow some very interesting rule, that is 9.2. Okay, here what we got here we got angle AOB, that is A to O to B. This angle should be equal to 2 times the angle ACB. Why? Because of this. We have a circle, we have a center, we have two lines joining them. Okay, and a position here where another angle is there. So 9.2 is applicable here. So that is the one we are getting it here. So now after doing this, what we will do is we follow the next step after that. Angle AOB will be equal to ACB. You go to the given here. In the given statement, it was written that angle ACB should be taken 90 degree. So we'll do that. 2 into 90 degree. So this will give me angle AOB should be equal to 180 degree. What does this mean? This means that AOB is 180 degree. What is the meaning? Another meaning of that is AOB is a straight line, because straight line is the one which is 180 degree. So quickly I can write, so AOB is a straight line, or what does that mean? AB is the diameter, because from the center you cannot have a straight line which is not diameter. Okay, remember, from the center you are drawing a line from one end to the other, and you cannot make a non-diameter. Okay, it has to be a diameter, isn't it? Just recollect. So AB is the diameter. So that means what? So AB is a semicircle. So we have proved that this AB is a semicircle. Very easy. So this is how we finish 9.4, and it is a converse of 9.3. Okay, you do revise many times.